So over here, I will show you how to interpret a multicollinearity check. We click on this triangle, we get the data into global environment. Do you guys have it? Okay. There are some good things about our Markdown. Running code is really simple. Then we set in data set as panel, because this particular data set is panel. And the way to detect is if you have a year variable, and if year variable has different values, like different years, that means your data set needs to be panel. And this is the code to set a data set as panel, and you need PLM package. So we set data set as panel. Then we run linear regression. This one is different from the previous one. I added P imputed, a poverty rate imputed variable. And the reason I did it, obviously, a level of poverty in a particular state can affect premiums. And the mechanism is simple. Like poor people, they don't have much purchasing power, right? So if you have like lots of poor people, it might like reduce. It actually will increase premiums. Anybody knows why? If you have lots of poor people in a state, premiums could be higher. Well, thing is, companies, insurance companies, they do risk pools. And for a balanced risk pool, you need as many people as possible. If you have like lots of people of like different kinds, it means you might have some young people, some old people, and there could be some like healthy combination of this stuff. But if you exclude a large portion of the population from your risk pool, it is possible you might have like a bunch of old and sick people who will use insurance a lot. And if you in your risk pool, you have people who use insurance a lot, when insurance company calculates premiums every single year, they probably decide to increase premiums. So again, when you have variables in your model, you have a reason to do so. And this is all based on the paper I asked you to read for Monday. And here I give explanations for variables, so it's easier for you. Again, little exercise. What can we say about this adjusted R-square in this model? Anyone? Yeah, changing. And when you do it, you must be very specific. 38% of change or 38.3% of change in premiums is explained by independent variables in the model. So whenever you interpret stuff, you must name your variables so understand what you are talking about. And then we have, do we have statistically significant coefficients? Is this one income, inflation adjusted, is it statistically significant? Yes, no, look at this stuff. Yeah, so you do not interpret the coefficients which are not statistically significant. What about uninsured? Yep. What about share of young adults imputed? It's kind of weird. It has very small dot. So it's like, I don't know. It's, I guess it's, what is it? 0.1, it means 90% confidence interval. You see? So whenever you interpret stuff, look up over here, and you see a small dot, which over here indicates 0.1, which means 90% confidence level. Okay, is variable poverty rate imputed statistically significant? Yes, no, maybe. Yep. What about post variable? Yeah, it is significant at like 99% level. And we remember I showed you, oops. I showed you, it always makes sense to look at the variables. So post variable, once again, it's an indicator when Trump policies regarding healthcare started being implemented. And again, values of 0 when Trump wasn't president, and values of 1 when he started implementing his policies. And since we already know that premiums is actual like dollar values, we can say that once Trump policies became implemented, and again, the change is from 0 to 1, right? There's only one change from 0 to 1. Premiums increased by $165. Okay, let's check for heteroscedasticity. We have this plot. So what can we say about this plot? Anyone? Yeah, there seems to be like a pattern here, right? So our residuals are not random. Okay, let's check for multicollinearity, the topic of today's class. For this, you need a car variable. It has nothing to do with cars. And if you don't have it, you need to remove hashtag. And you need to run this stuff. If you already have it, like leave it as it is. And the code for calculating a variance inflation factor, which allows us to check for multicollinearity, is pretty simple. VIF and name of the model. And you see over here in line 71, I assigned this name, but again, it could be anything. So let's check for multicollinearity. Oops. So, and I gave you, yeah, I'm trying to be nice. I gave you parameters for interpretation. So are there any problematic variables in this model? Which ones? Yep. So this indicates that these two variables create multi-collinearity in the model. But thing is, thing to understand, assumptions in regression, it's better if they're met, but you kind of can get away with violating them. So for instance, when we run the model, not like this, like a model with just a few variables, but the full model with like all the variables we have in the data set, we did have multicollinearity, and we submitted it to a journal, and so associate editor gave us a desk rejection. She said, guys, you have multicollinearity, like get lost. So what we did, we found another journal and we published it. But it was like less prestigious journal. So I won't get a Nobel Prize in economics for this paper. You won't see my name among Nobel Prize winners in economics. But if you want Nobel Prize in economics, you're not supposed to violate assumptions. That would be it for today.